Hello everyone. In the last videos, we have discussed how electrical power is generated from different sources of electrical energy. While generating the electrical power, we have to consider the load demand on a station. For that, we have to study the economics of power generation. In this video, we will be discussing on economics of power generation. There are some terms associated with economics of power generation. First is a load curve. A load curve is a curve showing the variation of load on power station with respect to time. It can be daily load curve, monthly load curve or annual load curve. Here it shows a daily load curve which shows variation of load on a power station in 24 hours of a day. If it is monthly load curve, it can be obtained from daily load curve which uses average values of power over a month at different times of the day. Monthly load curve is generally used to fix the rates of energy, the cost of energy. And we have annual load curve or yearly load curve, which is obtained by considering the monthly load curve. Yearly load curve is used for determining the annual load factor. The importance of load curve is that from the load curve, the area under the load curve gives total energy produced in a power station for a day. The area under the daily load curve gives the total power generation for a day. And the maximum point on the load curve gives maximum power demand on the station for particular day. And if it is annual load curve, the maximum demand, annual maximum demand is obtained from the load curve. And the average load on the system is obtained from the area under the load curve divided by the time gives average load. So the importance of load curve is daily load curve shows the variation of load on power station during different hours of the day. And the area under the load curve gives number of units generated in a day. Units generated per day equal to area under the load curve. And highest point on the daily load curve represents maximum demand on the station on that day. The area under the daily load curve divided by total number of hours gives average load on the station. And the load factor equal to average load by maximum demand is also obtained from the load curve. The load curve helps in selecting the size and number of generating units. Load, Depending on the load schedule, we can fix the size and number of generating units to be operated in a station. The load curve also helps in preparing the operation schedule of the station. Depending on the different time, we can prepare the schedule of operation. Some important terms and factors associated with economics of power generation are connected load. It is the sum of continuous ratings of all the equipments in the supply system. Then maximum demand. It is the greatest demand on the load on the power station during a given period. Connected load is the total equipments to be connected or maximum possible equipments can be connected in the system. And maximum demand is the maximum load occurring in a certain period of time. So maximum demand is usually less than the connected load because all the consumers will not switch on their connected load at a time. The knowledge of maximum demand is very important as it helps in determining the installed capacity of a station. The installed capacity of a station should be such that it should be more than the maximum demand. It is determined by knowing the maximum demand on the station. Installed capacity should be such that it should meet the maximum demand, also some amount of reserve capacity. The station must be capable of meeting the maximum demand. Demand factor. It is the ratio of maximum demand on power station to the connected load. Maximum demand by connected load. We know that maximum demand is always less than the connected load. So demand factor is usually less than 1. The knowledge of demand factor is vital in determining the capacity of the equipment. If demand factor is uh, low means maximum demand is low and the capacity is low. Capacity of the power plant is low. Then average load occurring on the power station in a given period is number of units generated in a day by 24 hours is daily average load. Number of units generated in month by number of hours in a month gives monthly average load. And number of units generated in a year divided by hours in an year, that is 365 into 24. 8760 hours gives yearly average load. Another important factor is load factor. It is the ratio of average load to maximum demand. Load factor equal to average load by maximum demand, or it is equal to unit generated in T hours, average load into time, divided by maximum demand into T hours, time of operation. We know that average load is always less than the maximum demand. So load factor is always less than 1. And higher the load factor on power station means lesser the maximum demands. That means lesser the cost of power produced, lesser the maximum demand. So higher the load factor, lesser will be the cost per unit generator. Next is diversity factor. It is the ratio sum of individual maximum demands to maximum demand on the power station. Sum of individual maximum demands by maximum demand on the station. We know that each equipment have some maximum demands, but all the equipments will not be operated at its maximum demand for a particular time. So sum of individual maximum demand will be always less than the maximum demand on power station. So diversity factor is always greater than 1. Greater the diversity factor means lesser the cost of power generation, because greater the diversity factor means maximum demand is less, so lesser the cost of power generation. Next is plant capacity factor. It is the ratio of actual energy produced by maximum energy that could have been produced. That is annual kilowatt hour output by plant capacity into 8760. For annual plant capacity factor, 365 into 24, 8760. And we know that plant capacity should be such that it should meet the maximum demand and also the reserve capacity. So reserve capacity is plant capacity minus maximum demand. Then plant use factor is also similar to that of plant capacity factor. Only difference is that here the time of operation is considered. It is the ratio of station output in kilowatt hour by plant capacity into hours of use. It is not 8760. This is hours of use called plant use factor. Then units generator per annum can be found out from the load factor. Load factor equal to average load by maximum demand, or average load equal to maximum demand into load factor. Units generated is average load into time, hours in an year. Average load is maximum demand into load factor into 8760. This can be used in problems for finding the units generated per annum. We have seen the load curve. Another curve is load duration curve. It is also similar to that of load curve. But here the load is represented in the descending magnitudes. Here in the load curve, we can see that from 8 hours to 16 hours, there is 20 megawatt generation. So that is the maximum. So first we will be drawing the 20 megawatt for 8 hours. Then 15 megawatt is for 4 hours. That is 8 to 12, 4 hours, 15 megawatt. Then 5 megawatt is for 8 plus 4, 12 hours. That is 12 hours, 5 megawatt. So here the magnitude is in descending order. The same data are obtained, but the curve will be such that the order of descending magnitudes. That is called low duration curve. These are the some main terms associated with economics of power generation. In the next video, we will be discussing some numerical problems using these load factors, demand factors, and other terms associated with economics of power generation. Thank you.